Hey everyone, so today we're going to work on derivatives and integrals with inverse trig. So inverse trig, you guys might remember, inverse trig, you have this little -1 here. Again, that doesn't act as a power, that acts as signifying an inverse. And you could also write that as arc sine, so these are equivalent. Typically I write it with arc because it's a little bit easier and I don't want you guys to try to do power rule with this, like bring it to -2 or 0 or whatever it may be. So again, these are the same things, and you'll see me use arc sine and arc secant, etc. a lot. So we're going to have to memorize these just as a heads up. And the nice thing about these, I know they look a little overwhelming. The nice thing is these three, so take a look. You have arc sine, arc secant, and arc tangent. Okay, these are your three little formulas here. Okay, and if you guys remember the word cofunctions, so sine and cosine, secant and cosecant, tangent and cotangent from trig. The only difference here, look at those, the only difference is we have a negative out front. Okay, so really you just have to memorize three of them. The other three, as long as you know what they're paired up with, like I said, it's cofunctions, sine and cosine, secant and cosecant, tangent and cotangent. If you know that, then you'll see that we just have a negative out front, and those are the only three you have to memorize. So when we talk about u, like this letter u, this is whatever we're taking the arc sine of, arc secant of, it's that inside piece. All right, so we're going to try some of these, and then we'll try some integrals with this as well. So take a look at the first one. Again, I'm going to rewrite this as arc sine. You don't need to, just a thought. Okay, we're going to find f prime. All right, so derivative of a inverse trig function. This is that u value, 2x. If you scan up here to arc sine, okay, I'm just reading off that first one, f prime would be 1 over the square root of 1 minus u squared. So 1 minus 2x squared, the whole thing squared, times derivative of u. So times the derivative of u would be times 2. All right, we simplify this a little bit. You don't have to, but typically you'll see it written this way. 2 over 1 minus 4x squared. And that is it. So again, just takes some memorizing, not necessarily hard to do, just if you don't know the formula, obviously it's going to be a little tough. All right, how about arc cosecant of 4x cubed? Okay, this should say d dx. All right, again, I'm going to steal it right from here. Okay, same thing as secant, same thing as secant but negative. Okay, and this is our u is 4x cubed, so it's going to be 1 over negative. So f prime is negative 1 over the absolute value of u times the square root of u squared minus 1 times the derivative of u. So times the derivative of this would be 12x squared. So again, if you want to rewrite it a little bit, negative 12x squared over the absolute value of 4x cubed times the square root. This would be 16x to the 6th minus 1. All right, so this would be a fine answer. And just to warn you, this absolute value, if you want to take out 4x squared, since that would be positive, you could simplify the top and bottom, and you might see this. So 12 and 4 could cancel to be -3. X squared and x squared could cancel, so you would just have absolute value of x left over. And then 16x to the 6th minus 1 would remain. And again, I just want to warn you of that. Again, when it's free response, you could write this and be done. If it's multiple choice, you're probably going to be looking for some answer like that. So I always want to warn you to simplify. Okay, and again, we took out a 4x squared. So let's try out one more here. Got a couple things going on. Okay, we have x times inverse cotangent, or arc cotangent. So let's rewrite this a little bit. X times, so notice we're multiplying two things together, arc cotangent of e to the x over 3, I'm going to write as 1/3 x. Okay, and I see I have these two pieces, f and g, two different functions multiplied together. So we're going to be using product rule. So you don't have to write this setup. If you're comfortable with this and have been doing this, maybe it's a good plan just to stay in that pattern and make sure you're finding all the pieces correctly. So f is x, and f prime would be 1. G is arc cotangent of e to the 1/3 x. The derivative, this is where it gets kind of fun. Okay, take a look up at the top of your notes if you need. Okay, it's -1 over u squared plus 1 times the derivative of u. So I should write a note here. U here was, e to the 1/3 x. Okay, so you can even write yourself a note. What is u prime going to be? It's going to be itself times chain rule of 1/3 x times 1/3. So up here, I'm writing u squared times u prime. U prime would be 1/3 e to the 1/3 x, using chain rule there. All right, so maybe simplify this a little bit. This whole thing together, okay, would be, let's see, this 3, you could have written like 1/3. So it's going to be in the denominator. We've got negative, so g prime. Sorry, I'll pick one more color here. So I'll write this final one in blue. G prime is negative e to the 1/3 x divided by 3 times, so I'm just moving this 3 to the front. E to the 1/3 x squared would be, if we have exponent times exponent, we just multiply. So it'd be e to the 2/3 x plus 1. Okay, and your final answer here, that's not it. The final answer, remember, we're doing f times g prime plus g times f prime. So in green, I'll write that final answer. We've got f times g prime, which was this whole thing, negative e to the 1/3 x, divided by 3 e to the 2/3 x plus 1, plus g times f, so 1 times arc cotangent of e to the 1/3 x. Okay, and that would be your final answer using product rule. We had an inverse trig in there, and we also had some chain rule, so a lot of things combined. All right, so we're going to try out number 4, if you're ready to go here. One more, bringing up that velocity and position, but using some inverse trig here. Okay, so take a look. It says the position is given as arctangent of the square root of 2t plus 1. Okay, and we want to find the velocity. Remember, the derivative of position is velocity, so we're going to be finding x prime of 24, which is, again, just the velocity at 24 seconds, or minutes, whatever this may be. It doesn't give units. So I would rewrite this a little bit as arctangent of 2t plus 1 to the 1/2. Okay, and again, this is u, is 2t plus 1 to the 1/2. You might want to write down what u prime is, just so that you're kind of ready to go. You'd bring down the 1/2, 2t plus 1 to the negative 1/2, and multiply by derivative of the inside is 2. 1/2 times 2 cancels, and we just end up with 2t plus 1 to the negative 1/2. All right, so u is right here. I'm going to pick a different color. In yellow here, that's u. And then u prime is right here. Okay, using chain rule there to simplify. So let's find derivative of arctangent is 1 over u squared plus 1 times the derivative of u. So x prime of t, which is the velocity, is 1 over u squared plus 1 times the derivative of u, that's right here. Okay, 2t plus 1 to the negative 1/2 would be 1 over the square root of 2t plus 1. That's exactly what this is. Okay, so I'm just going to write it that way. You could simplify a little bit. This is 1 over, the square root would cancel, so it would just be 2t plus 1 times 1 over square root of 2t plus 1. And then let's plug in 24. So what's the velocity at 24? 1 over 2 times 24 plus 1 times 1 over square root of 2 times 24 is 48 plus 1 is 49. This ends up being 1/50th times 1/7, which is 1/350th. Okay, and that is our velocity at 24 seconds. Okay, so let's finish up here, guys, with some integration with these. Now, the nice part is for Calc AB, the only ones we need to know are these 3. So notice tangent, sine, and secant. Again, these are arctangent, arcsine, and arcsecant. Okay, you're looking out for something that looks like this, and here is what your integral is going to be. Okay, so you only need these three. You do not need to go find the other ones. And just so you know, that letter A is a real number, so some real number, and U is the variable expression, or that inner function. Okay, so for derivatives, we do need to know all 6, but for integration, it's kind of nice. We only need to know these 3. And if you know the derivatives, you're going to see that connection right away. All right, so let's finish up here with 5 and 6. Okay, so again, you're looking out for that pattern, and you see that the first one is something over 1 squared plus 8x squared. And you might not recognize that, but overall what I want you to see is it fits into one of these patterns. Specifically, it looks a lot like arctangent. Okay, so let's try it out. The first thing I would have you do is rewrite it a little bit. So 8 times 1 over 1 plus 64x squared. Okay, and we want to look out for a squared and u squared. So you guys see these right here. So let's actually figure out what those are. Okay, a squared would be 1. So a is 1. Then we have u squared is 64x squared. So u is 8x. Right? And the reason we want to find these things is when we take that antiderivative, okay, if you look up here, it's 1 over a arctangent of u over a plus c. So if we have a and u ready to go, it's going to be pretty easy to plug in. So we're going to bring down the 8 like usual. We are going to multiply by, now antiderivative of this thing is arctangent of, oh sorry, I forgot to put, it doesn't end up mattering, but I should put this here, okay? 1 over a, so 1 over 1, arctangent of u over a plus c. Okay, one thing I want to note, typically you'd see this 8x, we have to do times du, so times the derivative of u, and that would be times 1/8. Because, it'd be times 8. We want to do that anti-chain rule. That's what I meant to say there. Sorry. So you guys know that from the past when we're taking that antiderivative, doing that anti-chain rule, we see that it's 8x, so we would divide by that derivative. Divide by 8. You'll notice the 8 and 1/8 end up canceling. 1 over 1 is just 1, so arctangent of 8x plus c. Again, we can always check these by trying to take the derivative. And you'll see why there ends up being an 8. Okay, that 8 ends up being there in the numerator since we multiply by the derivative of 8x. All right, so let's just try out one more here. Okay, take a look at 6. 6, you'll notice it looks a lot like arcsine. And if you don't notice that, it's just something to look out for, like 1 minus something squared. Okay, and square root of 1 minus something squared in the denominator. That's just a good thing to look out for. So let's rewrite this a little bit. 5 times 1 over the square root of 1 minus 25x squared dx. Okay, we're going to find this is a squared is 1, so a is 1. U squared is 25x squared, so u is 5x. Again, you'll notice we have the derivative of u out there. We know we're going to have to use anti-chain rule, so we'll end up canceling. That's something just to keep in mind. Okay, so arcsine here is just arcsine of u over a plus c, right up here. Arcsine of u over a plus c. Okay, so we bring down the 5 as usual. So 5 times arcsine of u over a plus c. And again, we want to multiply by anti-chain rule. So derivative of 5x is 5, so we want to multiply by 1/5. Okay, 5 times 1/5 end up canceling. Our final answer here would be arcsine of 5x plus c. Take the derivative to check if you want, and that's how we get that final answer there. All right, so again, take a look at these examples. Start memorizing these flashcards, write them down in your notes, highlight them, put them in a study guide. These 3, along with the 6 derivatives, are the ones you're going to have to memorize. So we'll try number 7 in class. Thanks so much for watching, and please let me know if you have any questions.